Hey everyone, back here for another screencast here. We're in Chapter 6, Lesson 7, and the heading is Parallelograms. Your learning target today is that you'd be able to find all angles of a parallelogram, of which there are 4 if you're only given 1, and the second part is that you'd be able to find the sides, lengths of a parallelogram. If you're given 2 sides, you'll need to find the other 2 sides. So first and foremost, what is a parallelogram? And if you don't have that heading up there, get that going up there, parallelograms. A parallelogram is a quadrilateral, 4 sides, with 2 sides that are parallel, or 2 pair of parallel sides. So if you can kind of use the lines on your notebook paper, parallelograms kind of look like that. And the way we show that the top and the bottom are parallel is you put arrows on them, just like we did our parallel lines. And the way to show you that the left hand and the right hand sides are parallel is you put a double arrow. Not a single arrow, because we've already used that one, and they're certainly not parallel to that. So that's a parallelogram. Now think back. It's kind of one of the benefits of having a mustache is you can do this while you think. Think back to the last lesson when we learned about parallel lines with transversals. Right next to that picture, draw a pair of 2 parallel lines, kind of on the same lines, that we had before, kind of like that straight. And then I want you to draw a transversal through here, and then another transversal through there. And notice that that forms a parallelogram. And so we're going to see a lot of the same principles from lesson 6.6, things like alternate exterior angles and the vertical angles from earlier in this lesson, as it applies to parallelograms. So I want you to keep kind of this picture in the back of your mind as we do some learning about parallelograms here. Going to get right to it. 2 big principles for parallelograms. Principle number 1, important principle number 1 is this. Opposite angles, and the word opposite in geometry means straight across, and we're talking about angles here, so opposite angles are congruent, meaning they're the same, and consecutive angles, and consecutive in geometry means next to. Consecutive angles are supplementary. Okay, so make a picture of a parallelogram right below that. And back at the beginning of this lesson I said your learning target is I want to give you 1 angle in a parallelogram, you give me the other 3. So this lower left angle down here, we're going to make that 60 degrees. So first principle up there says opposite angles are congruent. So straight across from 60 is up here, 60 degrees. And that's always going to be the case. And then the second principle says consecutive next to angles are supplementary. So right next to 60 you got an option of this one or this one. Doesn't matter because we know these 2 are going to be the same. Supplementary means adds up to 180. So to find out what this is, I'm just going to do a little sidebar math here. 180 minus 60 is 120 degrees. Therefore this angle is 120 degrees. And straight across this angle is 120 degrees. Okay, that's going to work for every single parallelogram. What do you get if you add all 4 of those numbers? 360. Right? Every quadrilateral's got 360 degrees as its measures of the interior angles. So that's important point number 1, opposite angles and congruent angles, and that'll work like that for every single parallelogram. Important point number 2 has to do with the sides, and it's this. Opposite side lengths are congruent. Opposite side lengths are congruent. This is an easy one. Draw a picture of a parallelogram right below this. Ignoring the angles on this one, we're just talking about sides on this one. So if you know one of the side lengths, let's just say that's going to be 20 inches, and you know over here is going to be 30 inches, and we're trying to find this side and this side, it's easy. Opposite side lengths straight across are congruent. The top's 20 inches, So is the bottom. If the right side's 30 inches, so is the left. Right, and just make sure you get your label in there. Use units if nothing's given. And that's it. Those are the two big ideas for parallelograms. Okay, I'm going to ask you to pause the video right now, and I'm going to put a problem up for you to try. But pause it right now and make sure you're good on your notes and everything's peachy. Alright, we're back. So what your goal is now, I'm going to have you pause this video again. You copy down this parallelogram, and I want you to find all the missing angles. Those are the 3 yellow ones. And all the missing side lengths. Those are the 2 blue ones. Alright, so apply the learning you've done. Pause it right now and do it. Pause me. Alright, let's check in and see how you did. So here's the best way of thinking through this. If this is 135 straight across, you should have had 135 degrees in the upper right hand part. Knowing that the consecutive angles are supplementary, 180 minus 135 is 45 degrees, and so your other 2 acute angles are 45 degrees. If the top's 45 meters, so is the bottom 45 meters. Opposite sides are congruent. If the left side's 50, so is the right side 50 meters. Alright, check it in. Parallelograms are pretty easy. That's what you should have had. One more little chunk to this lesson, and I'm going to have you make a hierarchy, kind of a tree diagram looking thing below this. We've got quadrilaterals. And this is kind of a review from your 6th grade year as well. So I want you to make quadrilaterals at the top of this tree diagram. And quadrilaterals that we're learning about right now can be classified as one of 2 things. Trapezoids or parallelograms. A trapezoid is a quadrilateral with 1 pair of parallel sides. Look at my abbreviation on that. That says 1 pair of parallel sides. Right? And so either the top and the bottom are parallel, or the left and the right are parallel. So make a little sketch of that. That's a trapezoid. 1 pair of parallel sides. Parallelograms a lot more involved. Parallelograms, we've got 2 pair of parallel sides. Make a little sketch of that guy, like we've been working with today. I want to give you a little more information on parallelograms because parallelograms sometimes travel under different and more specific names. Parallelograms can sometimes be called a rhombus. So make the word rhombus below this. A rhombus is a quadrilateral that's also a parallelogram. So make a flowchart down from your parallelogram into rhombus. But the rhombus has 4 equal sides. So it's got tops and bottoms that are parallel, lefts and right that are parallel, but put the little tick marks on the rhombus because all those sides are the same in order for it to be a rhombus. And then we'll go a little bit out of order here. Another quadrilateral that's also a parallelogram is a rectangle. Well, what makes a rectangle a rectangle? It's still a parallelogram, meaning it's got 2 pair of parallel sides, but a rectangle has 4 90-degree angles. And the correct geometrical way to draw a rectangle, as you know, make a rectangle down there, but then you need to mark your 90-degree angles. And then oftentimes we'll show that the top and the bottom are equal, because remember parallelograms have opposite sides that are equal, and the left and the right are equal. So put those little tick marks in there. The 2 means that the 2's are equal and the 1's are equal on that. What am I going to write next? Well, the most specialized quadrilateral is a square. A square is a quadrilateral that's also a parallelogram. What makes a square is 4 90-degree angles, just like a rectangle. Right, so technically a square is a rectangle, but a square is more specialized because it's got 4 equal sides. So the way you draw a geometrical square is you draw the square with the 4 90-degree angles in it, and then you put, like the rhombus, tick marks on each side to show that all 4 of those sides are equal as well. So I wanted you to have that hierarchy there of all of our quadrilaterals. Notice trapezoid is kind of lonely over there by itself, just got 1 pair of parallel sides. Parallelogram fills up, and I didn't put this in the best order. Rhombus kind of is its own thing. Probably should have moved that off to the side, but that gives you kind of an idea of what we're doing. Okay, you're going to practice some more things on your classwork all about parallelograms and their side lengths. Alright, this video again is posted in Moodle. Go back and watch it again if you need to. And thanks a lot, you guys.